Okay, so we're going to look at a third form of a line, which is called point slope form. And in the name, it's telling you the information that it gives you. From this form, we know a point on the line, and we know the slope of the line. I want to point out that's the same information we know from slope-intercept form. We know these same two things. We know a point on the line, and we know the slope of a line. Here's the difference. In slope-intercept form, the special point we know is always the y-intercept. And so we know the point's always going to be 0 something. That's a question mark. Or I'll put it this way, 0b. We get it from the equation y equals mx plus b. Right? It's always going to be, that's your y-coordinate, and x will always be 0 because it's a y-intercept. In point slope form, the point that we know is going to be x1, y1. It doesn't have to be 0 anything or anything 0. It can be any point. It could be 2, 3, 5, 7. It doesn't have to be the special point that's the y-intercept. So that's what this stuff is about here. It's giving us the form y minus y1 equals m times x minus x1, where m is the slope, x1 is the x-coordinate of the point that we know, y1 is the y-coordinate of the point that we know. X and y are variables in the equation. So here's some facts about it. It comes from the idea that the slope between any 2 points on a line is always the same. It's the idea that we have this consistent slope. The rate of change is constant. So that's where we can derive this formula from, or this equation from. And lastly, if we want to test that a point is actually on the line, if we want to prove a point is on that line, just like any of the forms, if we plug the points in, we'll get a true statement. In this case, we'll always get 0 over 0, which is a true statement. So let's do some examples. This is in point slope form. How do I recognize it? Well, I've got my y minus a number equals slope times the quantity, x minus the number. So I recognize it because I've got a slope times parentheses, and on the other side, it's not y equals. It's y minus the number. Okay? So that's how we're recognizing this form. You have to be able to tell the difference between, say, y equals 2x plus 3, which is slope-intercept form, or 4x plus 8y equals 7, which is standard form. So these are our three forms. This form seems to have a set of parentheses in it, which can help us tell it apart. Verify that 2, 7 is a solution to this equation. So that means this graph is a line, if I graphed it, and this point will be on the line. That's what it means graphically to be a solution. So if the point's 2, 7, I know the x-coordinate is 2 and the y-coordinate is 7. So I go y, I want to plug in the y-coordinate. So I'm rewriting this right here. I'm taking out the x and I'm taking out the y and putting in a blank. I'm putting the y-coordinate 7 from up here, and I'm putting in the x-coordinate 2 from up there. 7 minus 7 is 0. 2 minus 2 is 0, and 0 times 3 is 0. True statement. So 2, 7 is, in fact, on the line. Okay, so that's how we verify. Now, they give us the equation, and they want us to pull out the parts of it. So remember, there's two things that we know when we have this form. We know a point that's on the line, and we know the slope of the line. They want us to tell them those two pieces of information. So the point on the line is 1, 3. Notice that the x value is the one that's with the x, and the y value is the one that's with the y. Notice the signs are also the opposite because the form is written as y minus y1. So whenever I see a formula that has a negative sign in front of my variable, or not variable, but this is the number that I'm going to actually have there. When I have a negative in front of that, it means take the opposite sign. That's how I read formulas. If there's a negative there, it means it's the opposite of whatever's there. That's, again, how I read formulas when I read them. All right, so be careful with that. It's got to be the opposite things. The slope is always the number in front of the quantity. So our slope is 2/5. So then what do they want us to do? They want us to graph the equation. Well, I need 2 points to graph a line, so the easiest way to do this is we know 1 point on the line is 1, 3. And then slope always tells us how to get from one point to another. So just like when we had y equals mx plus b, we would first graph the y-intercept. Then from there, we would use the slope to come up with our new point. We're going to do the same thing, except our starting point's not going to be a y-intercept. It's going to be whatever that point was that we got. Right? So again, I'm going to do this on the side real quick just to remind you. Slope-intercept form, y equals 3/2 x plus 7. We know 0, 7 is the y-intercept, so we go up to 0, 7. Then we use the slope and say go up 3, right 2. There's our other point, right? So it's the same idea, except our starting point here is going to change. Right? It's not always going to be a y-intercept. Here we know it's 1, 3. We know the slope is 2/5, so we go up 2 and right 5. 1, 2, 3, 4, 5. There's our point. We can go the other direction. -2, -5. Because that's still going to be a positive, a negative divided by a negative. And there's our line. Okay? So it's kind of similar to what we've been doing. It's just how do we figure out the point that we start at? All right, let's do a test. So let's pick a point on the line. That point here, it was 1, 2, 3, 4, 5, 6. So this point is 6. And then up 1, 2, 3, 4, 5. 6, 5 is that point. So we can test it. If I plug in 5 for y and 6 for x, right, because it was the point 6, 5. So my x goes in there with the x, and the y, sorry, I did that backwards. My x goes in here with the x, and my y goes in there for the y. 5 minus 3 is 2. And then I get 2/5 times 6 minus 1 is what, 5? And I get 2 equals 2/5 times 5. So if I do 5 divided by 5 first, I get 1, and then 1 times 2 is 2. I get a true statement. So that point is on the line. Okay? Test your point in the equation to be sure that the point makes the equation true. So I picked the point that I found. We could test. I think they actually want us to test. This handout wants us to test this point that we pulled out, 1, 3. This will give us 0, 0 because it's the one that's actually in the form. So 3 minus 3 equals 2/5 x. Whoops, I got to plug in my x, which was 1 minus 1. So I took the 1 and I took the 3. All right, so that's what they wanted us to test. I just showed the other point also as on the line, but they want to make sure the point we pulled out is correct. So you can plug it back in and get 0 equals 0. 2/5 times 1 minus 1 is 0, and 0 times 2/5 is 0. That's what they want us to do. Let's try this one. The point on the line is 2, 8 that I pulled out. The slope is -3/2. Let's test our point. So I have, if my y value is 8, I plug it in. I should write the equation again, make this a little more clear. So it's y minus 8 equals -3/2 times x minus 2. So my y value of 8 gets plugged in here. My x value of 2 gets plugged in for this x here. And I get 0 equals 2 minus 2 is 0. 0 times the slope is 0. So my point is correct. I guess that's a way to check that you pulled out the correct point. What they're going for here is if you forget to take the opposite, since it was -8, if you put a -8 down here, this will not check out and you'll know you're wrong. That's what they're going for here. Whoops. Okay, so if you're careful taking out and switching your signs, you should be good. Now let's graph it. So we'll graph the point 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then our slope is -3/2, so I go down 3 and right 2. Could do it again, down 3 and right 2. All right, let's look at this guy. The point is going to be -5 now because it's a +5 that I see here. And remember, I'm picking, basically what you're doing is you're picking out the number that would go in here for x that would make this 0, essentially, is what happens. And then this over here is 2 because the y value, right? So that's another way to look at it. So there's our point, -5, 2. Our slope is 4/5. Let's test that point. If I plug 2 in for y, right, I'm taking the 2 and plugging in for y, I got 2 minus 2 equals 4/5 times I'm going to write that out now. X was -5, so if I plug my -5 in for x, I get -5 plus 5. I get 0 equals 4/5 times 0. I get 0 equals 0. So we did pull the point out correctly. So now if I want to graph, I'm going to go graph -5, 2. 1, 2, 3, 4, 5. 1, 2. There we go. And then we're going to use the slope 4/5. So I go up 4, 1, 2, 3, 4, and right 5. 1, 2, 3, 4, 5. There's my 2 points. I can graph my line. The point here is going to be -2 because that's what I would plug in to make that 0. You can think backwards like that. And that would be -6. And then our slope is 3/2. So let's see. We'll test our point. -6 plus 6 equals 3/2. -2 plus 2, I get 0 equals 0 because -2 plus 2 is 0. So our point is right. Let's graph -2, -6. 1, 2, 1, 2, 3, 4, 5, 6. Let's graph our slope up 3/2. I'll do it again just because I have room. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. There we go. Ooh, that was bad. I'm going to try again. There we go. That's better. Okay. So the next thing we're going to do, we're going to finish the rest of this in class. We're just going to do A and B together here. This time they give you a point and a slope, and they want you to write the equation in point-slope form. So remember the format is y minus y1 equals m times x minus x1. So this is your x1 and y1, right? Because that's how points go, x and then y. And this is your m. So I've got y minus y1 is 5 equals m, which is 2, times x minus x1, which is 3. Okay? Let's look at this last one. Here's my x1. There's my y1. And then this is my slope. So I got y minus y1, which is 6, equals m, which is 2/7 times x minus x1, which is 2. All right, we're going to finish the rest of this worksheet in class. You just need to have up to number 3 done when I check your homework.